So we're going to go ahead and solve this problem. It's a precipitate problem, and in the end we're going to draw two particle diagrams that will represent where those ions are before the reaction and after the reaction when we have a precipitate that has formed. So we're going to go ahead and start with the math first. And I've got some things written out. So basically we have these two solutions. We have this balanced reaction, and we're going to use the molarity equation to find how many moles of each of these compounds is in solution. So we set it up with the molarity equation, so 2.50 concentration, molarity, and we have 0.160 liters, right? That's 160 milliliters. Turns out that we have 0.400 moles of barium chloride. And then we're going to do the same thing here for lithium sulfate. We have the concentration of 2.50 moles, molarity, sorry, moles per liter. And we have 200 milliliters, which is 0.200 liters. So we solve for X, solve for the number of moles, and we end up with 0.500 moles. Okay, and I'm putting them here in the have box because we're going to need to know how much we have, and we're going to use the balanced equation to give us the ratio of what we need to react for the reaction. And it turns out that it is a 1-to-1 ratio, right? For every 1 mole of barium chloride, we need to react 1 mole of lithium sulfate. And now we're looking for the limiting reactant, right? So this is kind of an easy one because we know that this is a 1-to-1 ratio. We would need 0.4 moles of lithium sulfate to react with 0.4 moles of barium chloride. So it turns out that the barium chloride is the limiting reactant, and we will have excess excess reactant, lithium sulfate. Now, this is not all of the excess. There will be some excess left over after the reaction. So this is a fairly easy problem, but we're going to go ahead and first figure out how many ions we have. Okay. So if we have 0.400 moles of barium chloride, this will dissociate into 0.400 moles of barium ions, and it will dissociate into 0.800 moles of chloride ions, because there's 2 chlorines in every one of these, right? 2 chloride ions for every 1 barium. If we do the same thing for 0.500 moles of lithium sulfate, again, these will dissociate, these are aqueous solutions, into 1.00 moles of lithium ions, because there's 2 ions in every one of these formula units, right? And 0.500 moles of sulfate ions. Now the sulfate ions stay together. We're not going to break up the sulfur and the oxygen. So now we're going to go ahead and draw that first particle view diagram for these ions. Now we have to decide how many moles we want each particle to represent. And I'm going to go with each mole representing 0.1 moles. Each particle will represent 0.1 moles because we're going to have an odd number here and we're going to have some excess here. So basically what we're saying is we're going to have 4 particles here, right? Whatever we choose, circles, diamonds, etc. 8 particles here of chloride ions, 10 particles of lithium, and 5 particles of sulfate. So we're going to go ahead and draw that now. Now you have the legend already there, so we said we had 10 lithiums, so bear with me when I draw the 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 0.4 moles of barium, so that would be 4 of these hollow circles. And again, we're not really that concerned about the size of the ions right now. We have 0.8 moles of chlorine, so we're going to go ahead and draw 8 of these diamonds. 1, 2, 3, 4, 5, 6, 7, 8. And for sulfate, we had 5 particles, or 0.5 moles, which is 5 particles of sulfate. So we're going to draw 5 of these filled in diamonds. This represents 2, 3, 4. This represents all of the particles that are in solution that we are adding together before they react. Okay, so this is in solution. These represents the moles of each type of particle that's being put in. So now we're going to see what happens after the reaction. So the first thing we're going to do is calculate the moles of product, right? So we're going to use the limiting reactant. Remember, we can only make as much product as our limiting reactant will allow. So for both products, we're going to start with the limiting reactant. And we're going to carry out this mole-to-mole stoichiometry and figure out how many moles of this barium sulfate, now remember this is our solid product, and how many moles of our lithium chloride did we make? That's our second product. This is aqueous. So now we're looking and saying how many moles of each particle, of each ion, will we draw, keeping in mind that this is a solid, so when we draw it, we're going to draw those ions together in a solid. Again, this is going to dissociate into 1 barium and 1 sulfate. So we're going to have 0.400 moles of barium ions. So that will be 4 particles when we draw it in our drawing. And that will also be 0.400 moles of sulfate ions. Okay? And that will also be 4 particles when we draw it in our drawing. We are also making 0.8 moles of lithium chloride. And again, this is going to form 0.800 moles of lithium ions and 0.800 moles of chloride ions. Now these will stay in solution, right? These are not going to form a solid product. These will also be in solution. Now, what about this? Remember, we said we had excess, right? We didn't use up. This is a 1-to-1 ratio, and we have extra. So we need to figure out how much extra we have. Now you can see from here, just do the math, that we have 0.1 moles excess. It's not always going to be that easy, right? So we'll make sure we know how to do this the right way. What we're trying to find is how much of that lithium sulfate, that excess reactant, did we not use. So we're going to do a mole-to-mole stoichiometry with the 2 reactants. Okay, so we used up 0.4 moles of BaCl2, 1-to-1 ratio. We used up 0.400 moles of lithium sulfate, but we put in 0.500 moles of lithium sulfate. Right? So again, I'm just going to say that's how much we put in, and if you subtracted, which you could have done up there as well, 0.100 moles of lithium sulfate excess. Right? That is unreacted lithium sulfate, and these ions will be in solution. So we're going to have 0.200 moles of lithium ions, because again there's 2 lithiums for every mole, and 0.100 moles of sulfate ions in solution, not the ones that made product up here. Alright, so now we're going to go ahead and take these ions after reaction and draw them in, and we're going to make sure we draw in our unreacted excess reactant ions as well. So we had, let me just arrange this here, we have 4 barium ions and 4 sulfate ions that formed a solid product. So we are going to put that here at the bottom. So 4 barium ions, I'm going to put them like this, and 4 sulfate ions. So remember, they're forming a crystal, they're forming a solid that dropped out of solution. Right? So we need to make this look like a solid. These are not floating around in solution anymore. We have 8 of the lithiums and 8 of the chlorines. These are products that were formed, but they stayed in solution. So we're going to have 8 lithiums. So 1, 2, 3, 4, 5, 6, 7, 8, and 8 chlorine ions that again formed a product, but that product stayed in solution. So we're going to have 8 of those. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, this does not match here because we still have those excess ions, right? We had some stuff that did not react. And we had 2 more lithiums and 1 sulfate that did not form product. It just stayed in solution. So we're going to have 2 more lithium ions and 1 sulfate ion. This was excess. And these never left solution. Okay? So you've got your sulfate that formed a precipitate and some sulfate that stayed in solution. So if you counted up the dots and the circles and the hollow diamonds and the full diamonds, it should match what's over here. We're not creating any new ions or removing any ions in this problem. We're just rearranging them, right? A lot of them are staying in solution, but there is a solid product that drops out. You might even want to label it solid BaSO4, okay, just to show that that is what you're talking about. These ions are not in solution. Your calculations are solid. They form the basis for your drawings. And you could be asked a further problem. You could be asked for the molarity of any of these ions. Okay, so keep in mind that you added 2 volumes together, so you have a new volume. That's a problem for a different unit. Thanks for listening.